Good morning everyone. Today we're going to look at the ionic compound and how can we form any ionic compound. So the ionic compound can be formed by having, number one, by having a metal and non-metal. And we can also form the ionic compound by having a metal, and also the second is a group or atomic group. And now, as you know, how can we find the metal in the periodic table? We can find it on the left side of the periodic table. The non-metal can be found in the right side of the periodic table. Metal, we have group 1, group 2, and group 3. Non-metal, we have group 5 and 6 and 7. It is very important to know that the metal lose electron and change into positive ion. And the non-metal must gain electron and become negative. By having the positive ion and the negative ion, we can form the ionic compound, which basically the attraction force between the positive ion and the negative ion, there is attraction force between them. Now, I give you example for the metal and non-metal. Let's say if we have the first example, we have sodium chloride, table salt. We all know the sodium chloride, and now sodium is Na, as we know Na is metal, chloride which is Cl. It is very important when you write down any chemical formula, you must swap the valency. As we know, sodium in group 1, that's why the valency is 1. Chlorine gas in group 7, and because it's group 7, it must gain 1 electron to become 8, so the valency of chlorine will be 1, and 1 and 1, so it's already simplified, and it can be written as NaCl. Now, the second example we have, if I write down magnesium chloride. Now, magnesium chloride, how can we form magnesium chloride? Magnesium is Mg, chloride is Cl. And second step, you need to swap the valency. Magnesium in group 2, so the valency will be 2. And chlorine in group 7, it gains 1 electron. That's why the valency is 1. And it's already simplified, so you write it down as Mg, and you write the 1 underneath the magnesium. You don't have to write the 1. And Cl, it will be 2, because we have here 2, and the 2 here written under chlorine atoms. We have MgCl2, which is magnesium chloride. So by having, number 1, a metal and non-metal, we can form ionic compound. Second, by having a metal and atomic groups. We have 3 different atomic groups. We have the univalent group, I want to remind you, and we have divalent, univalent, divalent, and trivalent. Univalent, which has a valency of 1, and divalent has a valency of 2, and the trivalent, which is the group, has a valency of 3. The univalent, like OH hydroxide group, and we have nitrate NO3, nitrite NO2, and we have hydrocarbonate CHCO3, and we have ammonium is NH4, but this is the only positive group. And the divalent group, we have carbonate CO3 minus 2, and we have sulfate SO4 minus 2. The trivalent group, we have PO4, and it has a valency of 3, minus 3. Now, by having a metal and atomic group, I'll give you an example. Like, if we have the first example, magnesium, let's say magnesium, and I take hydroxide here, magnesium hydroxide. How can we write magnesium hydroxide? Magnesium is Mg, hydroxide is OH. Step 2, you have to swap the valency, and here magnesium in group 2, it's a metal, and losing 2 electrons. So the valency is 2. OH is univalent, so the valency of OH here is 1 because it's this group, it is univalent group. And now the numbers here 1 and 2 is already simplified, so you can write it down as Mg1, but if you have a 1, valency of 1, you don't have to write it down, and OH here 2, but here, because we have 2 atoms here, you must put here the this group, the atomic group between brackets. So it will be MgOH2. We move to the second example here. I'll give you a second example. Let's say if we have, again, we taking here a metal and the atomic groups. A metal, one of the elements in the left side of the periodic table, and the atomic group, one of the atomic groups here, univalent, divalent, and trivalent. A metal, let's say if I write down magnesium sulfate or calcium sulfate, or let's make it calcium, okay, sulfate. Calcium here is, as we know, the chemical formula or the symbol of calcium is Ca, sulfate is SO4. Second step, you need to swap the valency. Calcium is 2, because calcium, you find it in group 2 in the periodic table. Sulfate, one of the divalent group. And you have 2 here and 2 here. So when you have even number, and even number can be simplified. To divide by 2, it becomes 1 and 1. And as we know, if the valency is 1, so obviously we cannot write it down. So you don't have to write it down. So the chemical formula will be Ca1 and SO4 That's it. CaSO4, which means we have 1 calcium, 1 sulfur, and 4 oxygen atoms. And we move on to the last example here. Now, how about if we have magnesium phosphate? Magnesium phosphate. How can we write down the chemical formula of magnesium phosphate? Magnesium is Mg, and phosphate is PO4, metal and the atomic groups. Now we have a positive ion and negative ion. Magnesium here is one of the divalent group, like located in group 2 in the periodic table. So the valency is 2. Phosphate is trivalent, as we see here. So we write it here. We cross the valency, as we know, or we swap the valency. Now we have 3 and 2. So we have odd number, and here we have even number. So we cannot be simplified. So you write it down as it is. You write down 3 underneath the magnesium and 2 underneath the phosphate group. So it will be Mg. Let me write it down, Mg. And we write here 3 underneath magnesium. And then we write down PO4. And you have to write down 2 underneath phosphate group. But because we have here atomic groups which basically has different atoms, so you must put here the atomic groups between brackets. Now, if you count number of atoms here, we have 3 magnesium, and here we have how many phosphorus atoms? We have 1 times 2, so we have 2 phosphorus, and how many oxygen? We have 4 times 2, we have 8 oxygen. Now, to sum up, to form any ionic compound, we must have either metal and non-metal, or a metal and atomic groups. The metal lose and become positive ion, the non-metal gain and become negative ion. Now we have positive and negative like sodium chloride, and we have here second by having a metal, which is basically one of the left side, one of the elements in the left side of the periodic table, and the atomic group is one of these groups, which is basically all negative except ammonium, NH4 positive. Thank you for listening. Please, if you can share the video and subscribe now if you want to watch more videos. Thank you. Have a wonderful day.